Okay, Assalamualaikum warahmatullahi wabarakatuh. So I meet you today for the first weeks of this semester, but sadly I can't do live virtual class because I'm on leave for this week, but it's okay. So we start with chapter 1 with PST371, which is the plastic fabrication. In chapter 1, we will learn about the basic principle of plastic processing. Okay, so the learning outcome for this chapter will start to define the terms of polymer processing, to describe all general techniques of plastic fabrication, to distinguish all types of product produced by various types of fabrication technique, to identify all processing parameters involved by different plastic fabrication technique, and finally to discuss the factor affecting the product quality. So some introductions of plastic fabrication. Polymer processing is an art. It's not an art as looking upon entrepreneur, but it is a science relating to the flow and deformation of polymeric material, also known as rheology. So later on, when you further your study with degree programs, you will learn about the rheology, the behaviour of the plastic material, in terms of temperature, flow, mechanism, etc. Okay, why it says it's not an art? Okay, as presumed by the entrepreneur, but we know it as a science related to the flow and deformation, because this is the initial state where the polymeric material will identify the performance of the final products. So you need to know, in order to produce a good quality product, you need to know the behavior, the thermal properties, the polymeric property itself before you can form a final product. Polymer processing technology can be concluded as following statement. I do love this statement. Get the shapes, then set the shapes. So later on, when you further with your degree program, you will have another course introduced by product design, and here you will learn how to design a product in considerations of the properties and the behavior of the polymeric material itself. Okay, next, forms of plastic product available in Malaysian markets. Okay, so this is some of the what we call that plastic product that available in Malaysia, but not necessarily, not entirely concluded, because there is more and vast types of plastic being used, but this is most common. Okay, the first one is the molded plastic, or we call the plastic molding. Extruded forms such as the pipes and profile. Don't worry if you don't understand what's each of the equipment and the product. Later on we will cover each of these product, how it manufacture to produce the final product. Okay, and then we have films and sheets, usually we use in packaging. We have foams for packaging and cushions, laminates, applications such as for tabletops, usually use the thermoset. Laminate usually used to cover or to provide another properties to the certain material. For example, for tabletop, some of the tabletop is made from woods for their aesthetical values. Okay, so that the woods features is pleased to see. But however, woods, as we know, is very fragile toward the scratch, toward the mold growth, and it absorbs water significantly. So with the thermoset laminates, we protect the wood product so that it can be used as a tabletops and perform its properties. And then we have the adhesive such as phenol, epoxy resin, etc. Adhesive usually used in many what we call the assembly process, which is you use to assemble 2 parts, 3 parts, and etc. And some of it you use for painting industry to adhere the polymeric material towards the other material. For example, as we know, that polymer material is a the hydrophobic material. Surface of the polymer material is hydrophobic. So with this limitation, it's rarely to adhere properly on the surface of metal, ceramic, other plastics, woods, fabric, etc. So with this adhesive, it will enhance the capabilities of the adhesive and the coating or paintings to adhere on the other material surface. And then we have a coating compounds, which is mainly used as a pin, casting resin such as plastisol and GRP. And finally, we have a synthetic fibers, for example, textile fiber, etc. Synthetic fibers very well known and fast growing industries, such as to strengthen fabric material, for example, the bulletproof vest. And then we have anti-tear glove. Okay, to usually this product being used for what we call that, the 3D work, dangerous, dirty, and what we call the other one. I couldn't remember about it, but it's okay. The 3D industry. Okay, so the introduction for chapter 1. The first one is, okay, product or goods article may be produced based the following general technique. The first one, deformation of polymer melts, either thermoplastic or thermosetting. The fabrication technique involve extrusion, injection molds, and the calendering. The most important processing class. Next is the deformation of polymer in rubber state. Okay, this one you did not deform it. Okay, more on thermoplastic. The first one you melt it. The second one is formation of rubber state. So that means you did not turn the polymer material into liquid or the viscous method, but you just soften it. That is what we call the rubbery state. Okay, more on thermoplastic, the applications of the deformations of rubbery state, and then the fabrication technique involved of vacuum forming, pressure forming, warm forging techniques. And then deformation of a solution. We also have a solution material that finally transformed into a final product, either a thermoplastic or thermosetting. It doesn't matter. Both this industry is fast growing industry. Okay, the fabrication technique involved of extrusion in making custom and certain synthetic fibers and filaments. Okay, some of these deformation of a solution is not producing a final product, but is a secondary product or require another process to produce a final product. And then we have a deformation of suspension. Okay, this is very important with NR latex and other lattices with PVC piece. Okay, this deformation of suspension we will cover, I think, in chapter 8. Okay, we will go through that one later on. Although NR latex usually being used for suspension, but there is some materials such as PVC piece being used as the suspension. Okay, the product that being used commonly such as expansion of PVC that produce a foam. Okay, jadi macam apa, span basuh pinggan tu. That one we call the PVC paste that you transform into a suspension process to produce a foam. Deformation of low molecular weight polymer or polymer precursor, more on thermosetting method. This one is more on thermosetting. The fabrication technique involved of casting of acrylic sheets and preparation of glass reinforced laminates. This one more on coating of thermosetting material on other materials such as polymer, ceramic, wood, fabric, etc. And finally, we have a machining operation. Okay, the machining operation will focus on shearing force that has been experienced by material during the processing. Okay, some of the material require preliminary machining operation to produce a better master batch or a better what we call that, distribution of the materials. Okay, next we go to the plastic processing parameter. This is most important for plastic material. Okay, the parameters that will influence the final product properties. Okay, a successful finished product performance require knowledge, intelligence, and a flair on setting the processing parameter for all types of fabrication technique. So awal-awal you kena ada knowledge. So here today I give you a knowledge. Okay, next after you finish, you graduating your diploma, your degree, with that knowledge you convert into your intelligence. How you converting it, you solving a problems. Okay, with solving a problem you will minimize the flares on setting. So you will be very competent in setting the parameters for the polymer material, and finally minimize the defects of the final product. Okay, the knowledge requirement may in turn be subdivided into, there is 4. The product requirement, plastic material behavior. This is very important. I think you already covered the plastic material behaviors or properties last semester. Okay, so this semester I will touch a bit on the plastic material behavior, and then we have relevant fabrication technique, and finally all relevant economic and psychological factors. Okay, so in industry, usually the economic and psychological factors is the most contributing factors that doing the what we call that the selling price, the market price, the demand, etc. Okay, my probably in industry the economic and psychological factor will be the number 1, but we as science students, industry, we focus on more on the material behavior, product requirement, etc. Okay, but it doesn't matter, all of these requirement is very important to produce a good product with minimal defects. Okay, next, plastic processing parameters. Still in plastic processing parameters, there are several general processing parameters that always be placed their role in plastic manufacturing process as follow. Okay, this is most important in parameters for thermoplastic material. The first one is temperature. Okay, the raw material you need to convert to the final product, you need the temperature, either you deform or you turn into a rubbery state. Okay, temperature. Okay, the second one is time. Okay, how long it takes to deform the polymer material, how long it's taken to soften your plastic sheets to produce a final product. Okay, the third one is speed. Speed is very correlated with the product quality and the manufacturing cost. Okay, in industry, the speed will contribute in the quantity produced in what we call that a day productions. Okay, the higher the speed, the more product will be produced, so the higher the profit. However, the speed too high in speed might probably contributing in lower quality in terms of mechanical properties, the defect, etc. So you need to play around with the speeds. And finally, the pressure and stress. Some of the material require pressure and stress to form a good product. Some pressure required to have a polished surface of the final product. So these 4 parameters, okay, is very important, but it's not necessarily involved together. Okay, here it says that all processing parameters involved can be further discussed by different types of process. Some of the process may require only 2 parameters, temperature and time. Okay, some of it require 3, temperature, time, and speed. Whereas other parameters in polymer material, to produce the final product, you need all the parameters to ensure a good final product. Okay, For processing parameter for injection molding machine, the process parameter that usually control for plastic molded production by using injection molding as follow. Okay, so we go through with injection molding. Injection molding is the huge industry for polymeric material. It doesn't matter for plastic material, the rubber industry, latex, etc., and thermosetting. Okay, so the huge industry in polymeric industry is injection molding. So the parameters such as the melting temperature, which is the TM. Okay, TM is temperature of melting of material. Holding pressure, holding time, injection speed, injection time, injection pressure. Okay, all of these parameters I will go in detail in chapter 6 or 7. I couldn't remember, but chapter that focus on injection molding. And injection molding we have practical, so that we can go through the actual parameter setting that reflects on the final product properties. And then we have a regular extrusion machine. Okay, slightly similar but different machining, which is the extrusion machine. The parameter important to extrusion processing are similar to those injection or molding process. Let's say I did tissue on PST371, which is polymer machinery. I did elaborate lengthy on the extrusion machine. This is where you apply the processings of the equipment. Okay, the resin temperature, resin pressure, resin moisture content, moisture content also will contribute in final product properties. Screw speed, screw motor, and press are usually controlled or monitored to produce a homogeneous melt at a controlled volumetric rates. Okay, and then we have a quenching temperature and the rate at which the extruder is drawn are controlled or monitored to provide a controlled product size. Okay, as we know, the extrusion machine produce a continuous product, and some of the extrusion machine did not produce a profile with the which is the die size of the profile did not meet the final requirement, which is you require the stretching, okay, the drawn speed to provide required dimension, thickness, etc. Okay, this is where the what I call parameter that previously I mentioned, the speed play an important role. Okay, dimension measurement using a variety of gauging methods can be taken at the extruded as it is produced. In contrast to injection molding, extrusion can vary the size of final product I mentioned earlier without changing the die tooling. So this is the important parameters for stretching of your extruded material to meet the requirement of dimension and the thickness of the final product. Okay, and then common extrusion product tolerance of process consistencies are held to within 1% to the nominal measured value. As this manufacturing process involves a steady condition, any action that can stabilize any parameter condition is beneficial to the process. So eventually when you go to industry or you do your internships, you might probably be involved with this equipment, this machinery. So you will play around with the parameters or the certain condition in the industry, or because in environments of that machine itself, okay, to produce a final product, because the environmental parameter also slightly affected on the final product quality. And then we have extrusion blown film. Okay, this is also being covered in PST313. Last semester I did teach you about each of the equipment, the component, etc. For this semester I will focus on the processing parameter, the procedure to produce a good product, defect, etc. Okay, so we will go deeper on this extrusion blown film, and it's not limited to the specific type of film only, Later on, when we go to this chapter, we cover different types of the film that been produced in the extrusion blown film. The parameters that usually being considered and very concerned about the extrusion blown film. The first one is the melting temperature, screw speed, fan speed, drawer speed, and the winder speed. Don't worry about this. Later on, we will cover each of these parameters that affect things on the final product. Melting temperature setting for each zone and screw speed. Okay, so as we know, the blown film extrusion is a part of the extrusion machine. So the temperature for each of the zone is very important to make sure all of your raw material plasticize, okay, converting into high viscous polymer material, and the screw speed will contribute on the profile produced in the interval times, so that it can affect things on the dimensions and the thickness of your extruded parts. Okay, next, the thermoforming. What is thermoforming? Thermoforming basically is equipment that have what we call you heat up on the plastic sheet. Okay, thermoforming usually involved with the plastic sheets material. So your raw material should be in plastic sheets, and this plastic sheet, a piece of plastic sheets, will be heat up until it's softened, not until melted, until it's softened, or we call it reach the rubbery state. Okay, as it's heat up, it is softened, you will use your cavity to take a shape to produce the shapes of your final product. Okay, the most important parameter for this thermoforming is temperature setting for each zone. Usually for thermoforming, you will have at least 5 heating zones, okay, to produce a good set point on material. And then a sagging is at where the plastic sheets of material start to soften and it produce a sag. Okay, sags of plastic sheets, what we call the sag point. And then the heating time slightly related with the temperature setting. Some of the temperature setting you did not modify the temperature, but you play around with the heating time. And finally, the vacuum or the blow pressure. Some of the thermoforming use a vacuum technique, and some of it may use the blow pressure. Later on, we will go through what types of the thermoforming. I think we have approximately 7 types of thermoforming. Okay, each of the equipment slightly similar, but will yield a different product quality, and you might want to consider different types of thermoforming to produce a different types of product in terms of the applicable of that final products. And the factor affecting the product quality. Okay, I think this most important parts of this chapter. There are several factors which is that need to be considered in order to realize the potential of processed plastic material to meet the optimal level of quality as follow. The first one, the hygroscopic behaviour of polymer compound, the granule characteristic, thermal properties that influence the melting of the polymer, thermal stability, flow properties, thermal properties that affecting the coolings of the polymer, and finally the crystallization. We go through each of these factors affecting the product quality. The hygroscopic behaviours of polymer compound. What it is? Polymer compound shall be free of water and any boiling solvent. As we know, some of the polymer material it is a hygroscopic material. What is hygroscopic material? It is material that absorbs or capture any humidity in the environment. Okay, so that more likely these types of material we have a moisture in this raw material. So water can generate steam and can be trapped within the compound during processing and can lead to the void formation in a product. It also will form a mica marks. If a void were flattened, out through shear during the polymer flow. Polymer compounds are not hygroscopic materials, still can cause problem by the addition of hygroscopic additive. Okay, some of the material you produce, you add other additive. The additive will contribute on the hygroscopic material, such as material that you use the additive that you use is in a liquid form. So as we know, at higher temperature the liquid will start to evaporate first, okay, as the gas entrapped in the raw material will produce these defects, okay, such as void, mica mark, etc. Okay, next, the second one is granule characteristic. Okay, the regular shapes of the even size of granule material in all types of process will affect the following items. Okay, what it is? The first one can lead to much higher output rate, give more even heating process on material, and better control of flow properties. Okay, this is very important of the raw material that you try to pick up to produce your final product. As we know, the raw material, there is different shapes and types of raw material. Okay, some of it come in a cylinder forms. Okay, extruded parts, we call that extruded material. And then we have resin shapes, and then we have flake shapes, powder, and then crushed material. Okay, these types of granule characteristic will contribute in absorptions of the heat during the melting process. More consistent in size, or better consistency in granule size will contribute better heat transfer and will make more homogenized mixings and compounding, whereas more irregular material will might probably prolong the melting and the mixing process, and also may contribute in burning process, because the smaller size will start to melt, and while waiting for the bigger granule to soften and melt, the smaller size will start to burn. Okay, so this is the important parts of having more consistent in granule characteristic. But some of the material is more temperature friendly. I would say the higher temperature gradient will not affecting the burning process, etc. So it will be better for certain process. So for more material sensitive temperature require more consistent in granule size, etc. The third one, thermal properties that influence the meltings of the polymer. Heat required by polymer compounds may vary in order to bring up the processing temperature. This difference may caused by different specific heats of material. Okay, each of the material, as you go through chapter 3, semester 3 or semester 4, about the polymeric behavior, thermal behaviors of the thermoplastic and thermoset itself. Okay, each of the polymer is material having a specific TM, okay, melting temperature. So you need to consider the melting temperature of each of these material before you can produce a good product. Okay, as we know, the crystalline types of latent heat fusion of crystalline structure equal to, this is the equation, whereas the E is enthalpy heat of required in processing temperature, W is weight of the material as a specific heat, delta T is the difference between required melt temperature and ambient temperature at the latent heat of melting and crystalline structure. So usually in order to determine this melting and crystallization and soft TG, glass-to-transition temperature, you use the DSC, okay, differential scanning spectroscopy. Okay, this is for amorphous, slightly similar. Okay, not much to worry about this. Okay, heat of the melting can be formed from two sources. The first one, the external. Okay, usually this is very common, external. I think you will know about this. The heat transfer distance should kept to be a minimum, and the temperature distribution will depend on the thermal conductivity. Okay, whereas for internal heat generation can be generated either by high frequency heating process of the mechanical working during the processing. For example, the rotating screw in extrusion machine or injection molding itself. Okay, high frequency of heating provide less applicable of melt processing and frictional heat due to mechanical working, which can cause a significant distribution. And then high amount of frictional heat generation, friction between the there is three friction of material occur during the process. The first one is material with the material with the screw itself, material with the bare wall. Okay, this friction cause increased pattern in working rate and polymer viscosity. The fourth one is the thermal stability. Okay, fourth one is the thermal stability. It related to the ability of material to withstand a quite lengthy thermal history. PE and PS, okay, polyethylene and polystyrene may often be reprocessed in many times with little slight discoloration. Why? PE gives some deterioration in electrical insulation properties. Okay, PVC among the polymer can be more troublesome, which is need stabilizer addition, and even so may discolour and give off hydrochloride acid, the latter having a corrosive effect on many metals. Okay, the thermal stability is required. Usually what we do is we measure the operating temperatures of this raw material using the DSC itself. So when you use the DSC, you measure the starting melting temperature until the end point of melting temperature. This is the operating temperature of this raw material. So you need to take a precaution. Some of the material having a very narrow peak, which is the operating temperature is very what we call small. So you need to play around and to what we call control the temperature, so that during the process it will not the temperature is not increase more than required for the melting process. The fifth one is the flow properties. Flow properties of polymer mats are complex, of course. Why? Okay, polymer is trying to deform vigorously entangled long change molecule of a distribution of molecular weight. We know that each of the material having a different molecular weight. During the flow, stress imposed on the molecule will cause them partly to uncoil and possibly allow to roll over and over as they travel down the melt stream. When imposed stress are released, there will be a tendency to recoil. Okay, as we know, each of the backbone structure did not appear in straight line. Some of it having more amorphous than crystalline structure. So when you melt the polymeric material, it will easy to flow. But whenever you release the temperature, it starts to reorientate and it starts to recoil. This is the properties affecting on the flow properties. At higher temperature, material more likely easier to be flow. Okay, but at lower temperature, you might having a difficulty to maintain the flow properties. Okay, besides, flow may also be affected by additives. Some of the additives will increase the flow properties. Okay, the viscosity of the material. So some of the additive may contribute on unable of this material to be performed using certain equipment. For example, blown films, extrusion blown film. Extrusion blown film require a very I call that low viscosity. Okay, at the same time require more stability during blown process. Okay, or else it will start to collapse. And then the sixth, okay, the second last one is thermal properties that affecting the cooling of the polymer. Okay, after you heat up, you will start to cool it so that the raw material will take shapes of the dye, the mold shapes, etc. Okay, set the temperature of thermoplastic. Rates of the cooling effects of the process in two ways. First one, it influences the production rates. The second one, it influences the product properties. So you need to play around with these two process. So you don't want to have a higher production rate but lower product properties. Okay. At the same time, you don't want to have a very good product but very low in production rates. Okay. You need to play around with this so that it can achieve your targets in industry requirement. Longer times of solidification of polymer after injection, the longer will be the overall cycle. So it will affect things on the overall cycle time. It will finally influence the production rates of your industry lah. And then solidification of amorphous polymer will be determined by the value of Ti, okay, melting temperature in injection, and Tc, mold temperature, Tg, and average specific heat over the range of the ITG. Okay, while solidification of crystalline polymer will determine by value of Tc, Tm, latent heat fusion of crystalline structure, and average specific heat over range of Tm. And finally, the crystallization. What is crystallization? Provide an efficient way of packing a molecule. This packing raises the density and hence lead to much higher, much higher shrinkage on cooling from the melt that is observed with amorphous polymer. Okay, molding shrinkage crystalline polyolefin in range of 0.015 to 0.06, okay, centimeter of per area. Okay, amorphous polymer usually around 0.05 area. So what I want to show here is higher crystallinity polymer material will have higher shrinkage rate. So you need to consider of the shrinking behaviors of this polymeric material, so that when you produce a final product, the dimension of your final product will meet the required dimension. Okay, and then extent and manner of packing also influence mechanical properties of the product. Okay, some of the material and the product shapes require extensions of the applications of pressure using the packing, because of the mechanical properties strongly dependent on the pressure that you apply during the crystallization itself. Okay, I think that's all from me for chapter 1. I hope to see you, and if you have any question, feel free to contact me in a group so that I can try to answer each of your question for this chapter. By then, thank you, and I hope to see you again. Assalamualaikum warahmatullahi wabarakatuh.